Welcome, everyone. Good to see you again. This is week 2 of the Womanium Astrobiology program. Hope you guys are as excited as I am. To everyone here, I think a lot of you may know my background. I work in infrastructure and innovation in infrastructure. And typically our projects take 5, 10, 15, sometimes 20 to 30 years to get implemented. That's a long, long, long time. So I'm very excited actually for today's speaker, because if you use intelligent design and construction, you can get to delivery times faster. And to tell you how to do that and how NASA's Team X works, I'll let Tess introduce the speaker for today. But personally, I'm most excited for today's talk. And thank you everyone for being here today. Excited to see you all.
Hi, everyone. I'm really excited to introduce our speaker, Kelley Case. Kelley Case is the Concept Design Methods Manager for JPL's Office of Formulation. This means that she gets to work with a lot of people across a wide range of areas at JPL to make concurrent engineering, design, and analysis for mission concepts, for ideas that JPLers bring together to propose to NASA mission calls. So before everyone came in, Kelley and I were talking, and she described it as a crystal ball that she can kind of look and see what the future of JPL's position in the realm of NASA science is going to be like. So I'm really excited to hear about this. So she's going to talk about kind of a case study with an upcoming mission that's going to be launching very soon. And she will be able to share how the Team X would approach this and go through this mission concept formulation. So Kelley, thank you so much for giving us an hour of your time and for sharing this amazing work with us. Thank you.
Okay, great. So I'm just going to dive in here. So while one person might have an idea, it takes a whole team of people to turn that idea into a realizable mission concept. So as Tess introduced me, I manage all of our concurrent engineering design teams, and Team X is our advanced design team for putting ideas, for turning them into realizable mission concepts. It's about concurrent engineering, and I'll talk a little bit more about that. But basically, we put subject matter experts that work on flight project into the room. And so any major subsystems to design a spacecraft to go anywhere in our universe. It's about putting all the right people in the room to make that happen. And I love this quote, which is from our Team X lead engineer. It's really great to see a team come together in that collective knowledge. So the way Team X works is that ideas can come from anyone, anywhere in the room. It's not a hierarchy. It's really a room of peers. That's how we work. What I decided to do today is, rather than talk in theory about how Team X works, I wanted to do a case study, which is about how we formulated the Psyche discovery mission. This will be launching in October, and I've got links at the end of this presentation so you can learn more about the Psyche mission. But I thought it would be more fun to talk through this idea. So Lindy Elkins-Tatton is the PI, and she actually came to JPL in June 2013. Pretty much a decade ago, we've been working on this concept, and it's exciting to see it launch. Psyche has a great tagline, which is called Journey to a Metal World. So it's a competed NASA discovery program. Discovery programs are typically in the $500 million range, and I'll touch a little bit more about that. But it's the largest metal asteroid, and it's really about the formation of terrestrial planets, including Earth. So it's our first mission to a metal asteroid, and we will be launching in October later this year. Before I dive into that, I do want to touch on some fundamentals, which are basically the concept maturity levels. The reason that's important is it's about the framework for how our concurrent engineering teams work. And so the space that I actually work on is everything from what we call the cocktail napkin, which is a euphemism for ideas, all the way to looking through the initial feasibility of the concept, looking at the trade space, which is about how we might go about implementing the mission, and then doing a point design within Team X, that's CML4, and then doing a baseline concept, which basically aligns to a step 1 proposal, which is a book that more than 100 pages. If selected for a step 2 competition, which is a more detailed and integrated concept, 1,000 pages. I wanted to show you the thought that goes into everything from an idea to something that actually can become a mission. First off, the idea. So the PI came to us. She wanted a compelling discovery mission. She had worked on the Dawn mission. And at the time, we didn't even know what asteroid we were going to. But she was interested in doing the discovery mission of looking at an interior of a body for the first time by sending a mission to an iron metal asteroid. Originally, when she came to us, I don't know if you've heard of the A team, but A team is our architecture team. And so that's where we do ideation. We look at initial feasibility of concepts and then just look at the trade space of what we might want to do. So at the time we were looking at this, AO cost cap for discovery mission was actually $450 million. Even though the study was done in 2013, we were looking in advance for an upcoming call that we knew it was for discovery missions. So we wanted to make sure that we were feasible within that dollar amount. The reason I'm talking about this is you may or may not know about other planetary missions, but NASA, we have a very fixed budget. And of course, there's the debt ceiling and all of these conversations going on about budgets. And so it's really important to make sure that things are not just feasible in the engineering space, but they're feasible within the cost cap. For example, we knew that if we were targeting a discovery class mission, usually you look at analogies and analogous missions. And so we knew Dawn was a discovery class mission. They could afford 3 instruments. So we kind of knew that that's where we were targeting. It was also important to understand what we thought were the launch opportunities. There was also, depending on where the planets, how they align and everything, we wanted to look at what were different asteroids that we could actually visit within a certain time period. So I know that we're launching in 2023, but at the time we were anticipating that the date would be launching by December of 2021. It turns out that once the AO came out, they were interested in other target dates. So things do change. But what was interesting about this study is we looked at dozens of different trajectories and looked at somewhere between 25 and 50 different options on asteroids that we could get to within this time frame. And it turns out that one of the asteroids we could get to was Psyche. When the PI found out that we could go to Psyche, she lit up like a Christmas tree. It was like, wow, that's exciting. When she walked in the door, we had the notion of an idea, but we were really formulating the mission. So we put together a series of different studies, different subject matter experts. I started off with the cost and we look at cost, and then we did some mission design. But the next thing we looked at were, well, we can afford 3 instruments, but which 3 instruments should we take? So we were looking at, once again, different instruments, but also what are the hypotheses that we could explore? NASA is really about science and competed science. And so what would be interesting for us to look at? So we had a couple different ideas. We were looking at specifically different types of instruments, but also what measurements they enabled, and then looking at what were the different hypotheses. And so you can see that on the right, we were trying to look at what was necessary, but maybe not sufficient, what might be possible, what might be interesting hypotheses. So it was about understanding those gradients in the science return, depending on the different payload options. Once again, this was about exploring the trade space, about what things are possible. Also within that, wasn't just about the instruments. And if you're interested, I've got links in the back. You can explore more about what Psyche is actually going to do. But once again, I'm talking about formulating the mission and looking at all the possibilities. In looking at the trade space, it was about what is possible within and feasible within the discovery budget. We had a couple different questions. First off, what is the minimum amount that we could do for discovery? So it's important to understand that trade space of the minimum versus the maximum. What do we think would be really, really exciting? So we looked at, are there other targets that we could go to? We also looked at possible flybys. So you can see how we built on the different possibilities and looked at the first architecture seed, which was just orbiting Psyche. It was the minimum risk, what we thought we could achieve for a discovery class. Then we looked at what could we do about orbiting more than one asteroid. That's architecture seed 2. Then we looked at maybe we could do an orbiter and then maybe a flyby. So there were several different options there. And then we looked at orbiting multiple asteroids and maybe doing a flyby. Once again, we were trying to balance what is the minimum science that we could do versus, hey, what are all of the possibilities that we could look at? Once again, we had an amazing mission design person. His name is Damon Landau. He probably generated over 50 different types of trajectories. It turns out that what the Psyche mission decided to do is they actually opted for architecture seed number 1. And I know you're probably sitting there thinking, well, why would you go for the minimum versus there's all this other exciting things you could do? But part of formulation is thinking about your strategy, where you want to be on that scale compared to your competition. And so part of their decision was we actually want to be the low cost, low risk mission option. That's part of our capture strategy. So, when you formulate missions, there's lots of things to consider, not just the science and not just the engineering, but figuring out what that capture strategy is. Part of that was based on previous discovery missions. I just wanted to explain to you why they chose something that might appear less exciting, yet they really maximized their science for what they were planning to do at Psyche. The next part was interesting. So when you formulate a mission, you have to think about how you're going to implement the mission. So at the time, there was a few different players. Since then, of course, new space has expanded. And there's a lot more options how you might go about formulating a mission. But at the time, we were working with what was then Space Systems Loral. It later turned into Maxar. But at the time, we were looking to do a hybrid implementation with industry and looking at what we called a hybrid build, meaning that it would be partly built with industry, but primarily using JPL avionics. So we did more than one TMAX point design study. We actually brought in the people from industry and they worked side by side with our TMAX counterparts. We pretty much had doubled the size of our design team by bringing in the industry. Once again, we were thinking about the capture strategy and working with what we thought was a new player within the space industry. At this point, we understood the science we were trying to do. We understood the strategy we were going for. We understood our implementation piece. And these are all things to consider. And so at this point, we were really at a baseline concept. At this point, we were starting to write the step 1 proposal. As such, we also use Team X to review concepts. What we do is we try to mimic the way NASA puts together their panels. When NASA puts together review boards, they typically do what we call is an STMC review. And that stands for Science, Technical, Management, and Cost Review. And so we put together 2 panels. One is a science panel. We do the science evaluation. The other is technical panel. So that's looking at the implementation for the mission. NASA has certain evaluation criteria. Specifically, the science panel assesses the science merit and the science implementation. Then the technical looks at the mission implementation and the cost risk evaluation. All of those evaluation are actually publicly available. And so you can look up what the various criteria are for evaluation. And we use the same evaluation that NASA does. We try to mimic the same process that they use for evaluation. We use Team X to actually provide that evaluation. We provide feedback to the team, and Psyche team did an amazing job. We've done this probably over 50 times in TMEX, and they actually came up with very few weaknesses within our own internal reviews. However, they were also able to address the major weaknesses that we identified. So it turns out that they were selected to go to step 2. In step 2, it's interesting because in step 1, you don't know who your competition is, really. I mean, you hear rumors and you go to conferences and you hear lots of ideas of other mission concepts. However, for step 2, NASA only selects a handful of concepts to move forward in step 2. And they say, well, here's the 4 mission concepts that we're interested in pursuing. And they make you put together a very detailed implementation plan. But the interesting thing is you actually do have the NASA debriefs, all of your major and all of your minor weaknesses. And so at that point, you can start to address all of the feedback that you've received from NASA. So one of the feedback that they've received is, as I alluded to earlier, we had this hybrid spacecraft design. One of the things that NASA highlighted is they said, we're not clear on your management approach. And so basically, we paired the Psyche team with experienced proposal and staff people to work through these major and minor weaknesses. We paired the proposal team with experienced people, and sometimes you have what is truly a technical weakness that you really have to address. But we felt that this specific weakness was actually a communication issue. So it wasn't a technical weakness per se, but it was really about communicating properly. We worked with the team and we went through their entire proposal and worked through various communication issues from the step 1 proposal. You can see, we did an outline and whiteboarded this. This is just an example of the different types of artifacts and ways to communicate and fix some of their proposal weaknesses. Okay, so as I said, when the PI walked in the door, it was June of 2013. So we had 3.5 intense years really working on this concept. NASA had a press release on January 4th where the Psyche mission was actually selected. This is the NASA press release. I'm just going to be quiet for a minute. I feel like I'd rather everybody read it as opposed to me reading it for you. So I'm going to pause here for just a second so you can absorb the press release. So one of the guidance that we give to the teams when they're formulating a mission, and it's something that we do early on, is we actually say, imagine that your mission is selected. We try to help the team write and think about the press release while they're formulating. Now, of course, it's just an exercise in thinking about it. And this was not the actual press release that we thought of when we were formulating the Psyche concept. But it is an interesting exercise to go through that because at the end of the day, NASA is funded by the taxpayers. So you want to have really compelling science. And it's about why. So you have to answer those questions. Why do I care? Why should the public care? At the end of the day, we spend millions of dollars on a mission, but it's not so much the instruments and not so much about the spacecraft, while those things are necessary. It's really about the compelling nature of the science that we do. And at the end of the day, NASA wants that press release that makes everything truly exciting. That's really why everybody's here and interested in this conversation and this topic. And I realize I've gone through this a little bit faster than normal, but I do want to save time to have a discussion at the end. So here's some links, and I'll be sending out the slides for distribution, but there's certainly links. You can go to the JPL website and learn about the Psyche mission. The PI is actually from Arizona State University, and they have an amazing website where you can learn more about it. I've put a link in to an interview that a few of us did a few years ago, but it was done by Wired magazine, and it's about 4.5 minutes long. But it's a YouTube video that talks about the science of teams. I'm in it for about 30 seconds. It's about 4.5 minutes long. But there's some other amazing people in the video. Steve Lee, who is the deputy project manager for the Mars Science Laboratory. Then also it features Trina Ray, who was part of the Cassini science engineering team. So it talks a lot about the balance between engineering and science. So I hope you enjoy the video. That's more or less what I have for the talk. I really want to have an engaging discussion, and so I'd like to open the floor up for questions.
Thank you, Kelley. That was really cool. I didn't know all that. I learned a lot as well.
Oh, awesome.
We use a different server for questions. So I just want to share some of the questions from the students, if that's okay with you.
Absolutely.
So someone, Agatha from the UK, is asking if the CML scale is somehow analogous or different to the TRL or technology readiness level scale.
So that's a great question. So the CML scale, it's not necessarily a one-to-one mapping. However, the idea of the CML scale did initiate or originate from the TRL. And so, like I said, it's not a one-to-one mapping, but in working with teams, it helped us provide the framework for how to work with teams. The reason I chose the Psyche as a case study is because it did go all the way from idea to formulation. But sometimes, and it was selected on the very first time it was proposed. Oftentimes, a concept might take 2 or 3 times to propose it before it's selected. So depending on the maturity of the idea, we figure out how to help the team. If they've proposed before, they're well past the idea stage, but they may have a major weakness or might be a cost risk. So we do kind of back up in the CML scales, but it really helps provide the framework for how to work with the teams and what type of help they might need.
Great, thank you. And then Muhammad is asking if you have some advice for students who are interested in kind of getting involved in mission formulation.
Well, there's lots of different opportunities. Let me talk about one. First off, there is the Planetary Science Summer School. It is a competed opportunity. This year, we actually received funding to hold 2 summer school sessions. So we had one session, which was last week. That team chose to study going to Triton. They formulated a mission. We've got another team of students coming in next week. This is a competed opportunity, and that NASA provides the funding for. There's also an astrophysics mission design school that alternates with a helio. That opportunity is usually in the springtime is when we hold that session. So you should look up a PSSS. This year, it's the 35th annual opportunity. So we've been doing this for quite a while. There are usually about 20 students or so that are selected per summer session. The time to apply is in the fall timeframe. I'm not sure exactly when it comes out. Because it's competed, you do have to submit, there's an application and a selection process. There's the culminating week where you're actually at JPL and get to work with TeamX directly in the room, sitting with a TeamX member. But leading up to that, there's about 10 weeks of webinars. So similar to this program with 8 weeks, it is a commitment to participate weekly in the summer school.
And are foreign nationals allowed to be in that program, or is it only residents?
So foreign nationals are allowed to apply. We do have a limitation on the number that are selected, but you do have to be from a U.S., you have to be associated with a U.S. university.
Okay. I also want to highlight the Caltech Space Challenge, which is similar to the PSSS, and it is international. So that's something else you guys could consider. It's only 1 week. And it's a very intense week. We were about 16 hours a day, but it's also very similar. So that's something you guys could consider if you're not affiliated with the US institution.
Right, and that's, I think, in the spring timeframe usually.
Yeah, so the applications also are in the fall, and then it's a week in March that corresponds with Caltech's spring break, and everything is paid for. They fly you out and they give you your hotel and everything. So I really recommend looking into that comes the fall time. Okay, so some more questions. How many people are involved in each CML step? David is asking.
It depends. It really does vary. I would say as you go up the CML scale, you do involve more people. But initially, I would say when you're involved in the A team, we like to have on the order of 12 to 15 types of subject matter experts. But once again, it's about putting all the right people in the room. Depending on what the challenges are for that mission concept, we'll pull in subject matter experts as needed. For example, with respect to formulating the Psyche mission, depending on what we were doing, we pulled in somebody who knew trajectories of mission design. That was a big aspect, especially for planetary missions. The challenge is about getting to your destination. For earth science and astrophysics, it typically is more about the instruments. They tend to be a lot more complicated than the planetary missions. So with respect to earth science and astrophysics, it's about getting the data back because those are big, large data sets.
Thank you. Joshua from the Philippines asks, you touched on the compelling nature of the science and space missions and how it relates with public interest. Have there been any missions that were canceled or drastically changed because it wasn't interesting enough to the public or the shareholders?
Oh, that's a good question. I mean, I'm sure that there have been. Off the top of my head, I can't think about that, or I can't think of an example. I'm most familiar with the JPL missions. There is an ongoing conversation right now regarding the Mars sample return mission, regarding how much Congress has for that mission. Now, sometimes the science community, for example, in the last 2 decadals, the Mars sample return was priority 1 and 2 on the science list. And so there is ongoing conversations about how much money Congress has for this type of science. And then it becomes really a conversation about, well, if you have a certain cost ceiling, what can we achieve for that dollar amount? And so once again, looking at that trade space of what is the floor, what is the ceiling, and understanding what you can do in between. That's important. But off the top of my head, I can't think of a JPL mission. The Psyche mission did get delayed because we wanted to make sure that we did the proper testing for everything. So obviously we didn't get canceled. But there have been NASA missions, I think, at other centers that have been canceled.
Thank you. So Sarah from the US asks, is the concept process the same for both robotic and human or human robotic missions?
So JPL actually only do robotics. We don't do human spaceflight. Now, having said that, we actually TMX has done some studies and provided system level feedback for HLS, for the human lander system, but primarily JPL focuses on robotic types of and science missions. There's a lot of design principles that are very specific when you are working with astronauts. For example, when we deploy something to the International Space Station, because JPL has had some instruments that get mounted on the ISS externally, but there are certain standards, but I'm less familiar with them because JPL doesn't design for human spaceflight.
Thank you. Deep Sankar from India asks, is there a way scientists can predict the kind of metal and elements on Psyche that may be found, and how?
That is actually a really great question, and it's a very detailed question, and it's sort of beyond my expertise. However, I would encourage you to go to the website because the website does have a section on the science. They do have models on other missions on what they expect to see, and they do have science models with what they are expecting, and that also helped guided a lot of their step 2 detailed information in their science traceability matrix. That's something I didn't talk about, but when they proposed, they also, it's not just about what, oh, this is exciting science. You also need to propose, hey, here's how well we have to make the measurements, and here's why we need these instruments. And so if you go to the ASU website, they have a lot of that information. And so I don't even want to attempt to answer that question. By the way, we do over 100 studies in a year. And so there is no way I can learn the detailed science for all the 100 studies that we actually do in a year. I just kind of have vague, high level understanding of all of the missions.
100 a year. That's so many more than I expected. Wow.
Yeah.
How many are you working on at a time?
Oh, last week we did the science summer school. We did a study working with the Deep Space Network on optical comm and how that might be enabling for them to return more data missions. We also looked at Artemis deployed instruments, a couple concepts there. We did an A-team study looking at digital twins and how that might enable future concepts. So any given week, we look at maybe a handful of different ideas. Now, some of the concepts actually come back more than once. So for example, with the Psyche mission, we probably did a dozen different studies with them. And I tried to talk you through that with the different concept maturity levels. We do see teams more than once or more than twice.
Very cool. So Nicole was asking, could Psyche have a second part, such as a sample return or like some probe analysis in situ?
Psyche specifically wasn't designed to be a sample return. They definitely have different phases where they are doing orbits and getting closer and different type of science that they do. And so I do encourage you once again to go to the website, because I think they have like 4 different science phases. I don't remember all the details, but we are looking at other sample return missions. There's certainly some ideas from the Decadal Survey, Comet sample return missions. Those are things that have been proposed before. I would say that under a discovery class, a sample return is a little sporty. So probably for either a flagship or a New Frontiers class mission, New Frontiers is more on the $900 million range as far as the A through D implementation costs. And so I would say that sample return is definitely something doable, but once again, looking at price points and thinking about cost caps, it is a higher, more complicated type of mission and probably higher risk. So it would be more expensive than a discovery class.
Yeah, definitely.
I'm loving all the questions. This is more fun than my talk.
Yeah, the chat is flying. I'm trying to keep up. So Akila from the US asks about what are the new ways, or the ways that new ideas and missions are generated for different mission concepts?
We do have the A-team, and that's where we do a lot of ideation, and we try to bring in both scientists and engineers, right? Because you need that balance and realism, but ideas can come from anywhere. We've also had challenges, lab challenges on certain topics that we've done before, which can be engaging. Ideas, people sometimes directly go and work with the program offices when they have an idea for a new mission. So I work with a lot of the people on lab that do earth science, that do astrophysics, and that do planetary science. And so I work with those program offices, and they're well connected with the community. But ideas really can come from anywhere. And when you think about the ideas, though, you also want to think about the opportunities. So it's while these space challenges are a lot of fun, if you really want to enable an opportunity, you have to think about how it possibly might get funded. So it's not just enough to have an idea. You want a path forward. My former boss, it took me a while to understand this concept, but he said we had an offsite retreat, and those are always fun because as a team you get to regroup. And he said, if an idea, if it never happens, it doesn't matter how innovative the concept is. And at first, a few of us are like, no, we do ideation. And his point was, you want to make sure that you have a path to flight, because it's really about making things happen. So I hope I didn't squash the idea generation there. But anyhow, there are a lot of great ideas, and unfortunately can't fund them all, but it is about making science truly happen.
Great answer. Sarah from the US was asking about industry partners and like, what are your approaches to diverse and impactful mission partnerships? Do you generate diversity and balance impactful partnerships with organizations who are household names or have never done it before, and like what the process is for selecting them?
It varies, but we actually have a database. I have actually 3 team members right now that are at the SmallSat conference. We also have team members that constantly watch space news and monitor press releases from industry. So we do look at what industry is doing. We do look at what types of things, business that they're in. We do work with, of course, what I'll call like old space or traditional vendors, but we also do look at new space and what they're doing. One of the things that's important to think about is their business model, how they get funding. So it turns out commercial industry tends to drive a lot of the space industry. Only about 2% of all of the satellites that get launched are really associated with science, but a lot of them are associated with telecommunications, for example. So it's important to keep track of commercialization of the space industry, because that primarily drives what they do. And so trying to take advantage of what commercial space is doing is important for us to understand the science and understand if that's their primary funding source, looking for ways to leverage commercialization of the space industry.
Thank you. So Artem from Mexico is asking a similar question, but instead of with industry partners, how does the Team X collaborate with like a similar team from a different country?
We have an office here that works with strategic partnerships. And then once again, we also have the formulation program offices who have developed a lot of relationships with industry. Recently, NASA launched the SWAP mission, which was a partnership with CNES, the French space agency. Recently, we had the UK Space Agency come and visit JPL for a week. We've worked on NISAR with the ISRO, the Indian Space Agency. We have several collaborations with ESA and JAXA. So NASA and specifically JPL has a rich history of partnerships. And once again, going back to cost and how important that is, looking to partner with other agencies, international agencies, is a way where we can increase and maximize science by partnering. So JPL is always looking to do that specifically. You had any business you needed to handle here?
We'll try to end maybe 3 or 4 minutes early, but if you have time for a few more questions, I think that would be great. Okay, we don't want to overwhelm you either.
No, this is fun.
Great. I was curious. So is there, like, you look at 100 concepts a year, is there some sort of indicating factors over so many concepts where you're like, this one seems pretty likely to get funded, or is it not really that easy to tell from concept to concept?
I try to always look on the positive side about any concept, encourage the teams to lean into what are their specific strengths and what makes them unique. Once again, you have to think about what is your capture strategy and what is unique about your mission, what sets it apart from something else. And so if you could substitute another name in place of your mission concept name, then you're not unique enough. You're not setting yourself apart. So it is about why are you doing this mission? And so understanding your why is really, really important.
Thank you. So Sarah from the US asks, do members of Team X work exclusively on concepts full time, or is that just a portion of your time and you also work on actively supporting operations and research and such?
My full-time job is formulation and looking at all these 100 concepts or so. However, the Team X members that you saw in my slides in the room, they work half-time on Team X and half-time on flight projects. Partly that's because we want people on Team X that have true flight project experience. And so that's how we work with. So I work with the people that are from those organizations. So our telecom lead, for example, comes out of the section. He also works on the Psyche mission on the telecom subsystem. And so we do pull from the flight projects and the organizations that do that work. It's not like I have a standing team. I think that answered the question.
Yes, thank you. Sudha asks, are there any open resources available to learn simple mission design concepts?
This is one of those opportunities, and I've seen the list of speakers, and I think you've got some great speakers lined up. Once again, the Caltech Space Challenge, Planetary Science Summer School, but also just doing your own research. And I would say missions that are of interest to you, that excite you scientifically, go learn more about them. But that's also why I did the case study for Psyche. I thought giving you a practical example would be more interesting than just giving you definitions of what does it mean to be at CML4.
Thank you. I think we'll stop there. Thank you so much for your time, Kelley. I think I really enjoyed it, and I'm based on the reactions, everyone else really felt it was very valuable. So thank you for giving us an hour of your early morning over in California. We really appreciate it.
Okay, well, I had fun. I always learn something when I give talks like this because everybody asks interesting questions. So
very glad to have you join us. So thank you very much. Okay, so we are going to finish off with some announcements. We had some late signups, so we moved the keynote quiz 1, that was Morgan's quiz, to the deadline of this upcoming Sunday. That's on Canvas. Everyone should have, if you submitted a quiz, it should have been graded as of like a few hours ago. So everyone should have their results. The average was like a 90% or something really high. So good job. I'm really glad you were all engaged and able to answer the quiz questions. Please continue to use the Discord to find a team if you haven't already. We put the assignment on Canvas. It's an ungraded survey, so it's just a matter of entering your team member names, their email addresses. Please use their full names, and then just saying where your mission's going and certifying that someone can present in the live semifinals and finals. Finally, we're going to keep registration open, but today or so we can't really have people joining the mission design anymore just because of finding teams and the logistics. That's the announcements for today. These are all posted on Discord as well. Some bookkeeping, so please continue to use the Discord live questions channel. I will be monitoring that. I can't be monitoring the Zoom chat and live questions channel at the same time. So it's better if we keep all the questions in one place. Please try to use general chat if you're just talking for fun, because it keeps it easier because I'm trying to scroll through and listen to the speaker and talk to the speaker. So it's helpful for me if we mostly just keep questions in the live question chat. Prachi, is there anything else we need to add?
No, and just really to emphasize, only one team member has to submit the Canvas form. Include everybody on your team's name. Don't miss out on anyone. Get the email addresses because we are asking you for names, email addresses of your team members, and of course, where is the mission going to? But again, only one person from the whole team needs to submit this on Canvas. And just in terms of your grading, each one of you needs to do the Canvas quizzes, especially about the keynotes and end of the week quizzes. However, just as it pertains to the mission, that only the team leader should submit. So information on the team, later we're going to ask you a draft of your slides, of the presentation for the mission. All of that, we only want one presentation per team. So again, only one person per team submits that. Each one of you should still keep working on the Canvas quizzes, and good job with the 90%.
Cool. Okay, so then tomorrow we will be joined by Dr. Jessica Weber and Dr. Bonnie Teese, who are actually two of my colleagues at JPL. And they will be doing a question and answer session and talking about what it's like to be a lab astrobiologist. So I'm really excited to have them join us because they're from two very different backgrounds. Dr. Weber is a chemist. She didn't start doing astrobiology until after she finished her PhD. And then Dr. Teese, she's actually from Australia and was really involved in the Australian Astrobiology Initiative. So very excited to have the two of them join us. They're both friends of mine as well. We'll be having a good discussion about what it's like to be a lab astrobiologist. So we hope to see you all tomorrow.
Perfect. Keep your questions ready. Maybe post some questions in live questions itself. I'll make a thread and start posting questions there. I'll make a line cut and start posting questions there. So keep questions ready. Tomorrow is your time to ask questions and get started. So really excited for tomorrow. Thank you, Tess. You have good friends.
Yes, it's been very exciting to share with everyone. If you have not gotten the correct Discord link, send an email to biology@womanium.org and we will send you the correct one. All right. Thank you, everyone. See you tomorrow. Bye.